All right, and we're going to pick up from where we left off on Monday. So we're going to pick up looking at the point slope form of a line. And I am going to stop my video for bandwidth issues. Can everyone hear me sufficiently? Am I loud enough?
I can hear you perfectly.
Oh, great. Thank you, Nick. Let me share my screen. So on Monday, we had started looking at linear functions. And one of the most important characteristics of a linear function is its slope. So on Monday, we had gotten the equation, the formula, and a formula in mathematics is an equation where you know all the variables except one. So to find the slope, you need to know the values of 2 points on your line. And if you know the values of those 2 points, you can find the slope. Can you still hear me?
Yes, ma'am.
All right, thank you, because something just beeped on my computer. All right, so the slope, if we're given 2 points, excuse me, and these are just 2 arbitrary points on the line, and we designate them using subscripts just to show that we've got 2 different points. So we've got a point x sub 1, y sub 1, and a point x sub 2, y sub 2. And again, the subscripts just denote that there are 2 different points on this line. From that, we can find the slope by finding the change in the y coordinates over the change in the x coordinates. And then we use that equation of the slope, and we found an equation of the line, which we have right here, where what we need to know to find the equation of this line is 1 point. Again, why do we designate it x sub 1, y sub 1? That's just to designate that it's a point on this line. And we need to know the slope, which we can find the slope using the formula, or the slope can be given to us. So once we have these 2 pieces of information, we can find the equation of the line. And once we have the equation of the line, we can find any ordered pair that is on that line. All right, so let's look at an example. We're going to write an equation in point slope form for the line with slope 6. So they do give me the slope. M is 6. And that goes through a point to -5. And they also give me the 1 point, which is required for me to use this formula. And now it's a plug and chug. And I hope everybody's somewhat awake, because this is very important as you enter your answers into my math lab. So I'm going to write my point slope equation, y minus y1 equals m times x minus x1. And now I'm going to plug in. I'm going to put the -5 in for y1. The y coordinate of the point on my line is -5. So we're going to be real careful sign wise. We're going to put that -5 in parentheses. So it's y minus a -5 equals 6 times x minus 2. We're going to put the 2 in for x sub 1 and the 6 in for the slope. And now the only thing we're going to do the only thing we're going to do is simplify the left-hand side. So we're going to take that minus a minus 5 and make it y plus 5. And we're going to stop. That is as far as we are going to go. This right here is point slope form. So if my math lab asks you, excuse me, to enter your answer in point slope form, this is as far as you're going to go. You're going to simplify the left-hand side of the equation if you can. And only simplification you're going to do is if you have a minus, you're going to make that a plus. And you're going to leave the right-hand side of this equation alone. You're not going to distribute. You're not going to combine like terms. You're not going to put the 5 over on the right-hand side. That's a different form of the line, which we're going to talk about in just a second. So you're going to leave it in this form. This is point slope form. And the reason it's point slope form is because just looking at this, I know that this number outside the parentheses is the slope. So the slope of this line is 6. I also know that whatever I have here, the opposite of that is a y coordinate of a point that's on the line, because the point slope form says y minus y sub 1. That number plus 5, if I change its sign, then that's going to be the y coordinate of the point that's on this line. And then whatever I'm subtracting over here on the right-hand side of this equation, I'm subtracting 2. So the x coordinate of the point that's on this line is 2. So looking at this, I can see that the point on this line is 2, -5, and the slope is 6. So that's as far as we're going to take this when we are putting our answer in point slope form. Now, the next form of the line, which you may be more familiar with, and it's what we all want to do when we have it in this form, is we want to put it in slope intercept form. So let's get that form of the line. This is point slope form. Well, first we need to find another equation in point slope form. I forgot all about this example. All right, so what do we do here? Write an equation, got a typo right there. Write an equation in point slope form for the line passing through the point 4, -3, and -2, 6. All right, so here is point slope form. And I know a point, as a matter of fact, I know 2 points, but I don't know the slope, but that's no problem. As long as I'm given 2 points on the line, I can find the slope of that line. The slope is found by taking the change in y over the change in x. So I'm going to let this point here, the 4, -3, be x sub 1, y sub 1. And I'm going to let the other point, -2, 6, be x sub 2, y sub 2. So now we're going to plug and check. So we have 6 minus a -3, change in y, over change in x, -2, -4. Okay, that looks to be 9 over -6. I am going to divide out a 3. So my slope is -3/2. All right, so now I can take either one of these points and use that as a point in my equation. So I can use this one or this one. It doesn't matter. It honestly doesn't matter which point you use. They're both points on the line. And I'm going to plug that in along with the slope in my point slope form. So I just use the first point because it's the first point. Okay, so we're going to have y minus, whoops, come on, PowerPoint, -3 equals my slope, -3/2, x minus 4. So do I have everything plugged in there correctly? I think so. Change that a minus to a plus, and I am done. That's all I need to do. This is point slope form. I don't need to go any farther. I don't need to remove the parentheses. I'm done. All right. Now we're going to get slope intercept form. Okay, so now I have a line, and we know that it goes through the y-axis, so it has a y-intercept. And the y-intercept we call B. So this line goes through the point 0, B. If it's on the y-axis, its x-coordinate is 0. And it also goes through some arbitrary point x, y, and its slope is m. So I can use the point slope form of the line to find the equation for this line. Okay, so we have y minus y1 is equal to m times x minus x1. And I'm going to let x1, y1, my specific point on my line, to be 0b. Excuse me, I'm going to lose my voice. So I'm going to plug that in. X minus 0 is just x. Now I'm going to move the minus b over to the right-hand side of the equation by adding it to both sides. And we get point slope form. Slope intercept form, excuse me. This is slope intercept. Why is it called slope intercept? It's called slope intercept because the number you're multiplying times x, that is the slope. And the number that you're adding on the right-hand side is the y-intercept. So whatever this number is here, that's the y-intercept. So you can look at this equation and you can determine the slope and you can determine the y-intercept. And this is probably the most common form of the equation of a line because it is so easy to use. So if you take any one of the things that we've already done, if you take this equation that we just did and you solve this for y, that is slope intercept form. So when we have y on the left-hand side by itself and x and a constant on the right-hand side, that's slope intercept form. So slope intercept form is y equals mx plus b. So just looking at an equation of a line, if it's solved for y, then you know the slope is the number you're multiplying times x. So the slope is 2, and the y-intercept is -4. In this particular equation, we do have it written in function notation. That's fine because f of x and y are exactly the same thing. Exactly the same thing. So again, the slope for this particular equation is 1/2. It's what you're multiplying times x. And the y-intercept is 2. It's the constant on the right-hand side of the equation. All right, so you can use slope and y-intercept to graph the equation of a line. So there are 3 methods for graphing an equation of a line. You can plot points. And we've been doing that now since section 1.1. That's the first thing we did this semester, is we plotted points on the coordinate plane and got the pictures of equations. And then in we can use slope and y-intercept also to graph the equation specifically of a line. So to do this, we're going to follow these steps. The first thing you're going to do is plot the y-intercept. Remember that constant that you're adding to the x term on the right-hand side of your equation is the y-intercept. So you're going to plot the point 0b. Then you're going to use the slope to find a second point on the equation of your line. And to do that, remember the slope is the rise over run. It's the change in y over the change in x. So the slope is going to tell you the direction you go in the y and the magnitude you go in the y, and it's going to tell you the direction you go in the x and the magnitude you go in the x. So to obtain a second point using slope, write m as a fraction and use the rise over run, starting at the point containing the y-intercept to plot the point. Then you draw a line, and it tells you to use a straight edge. Honestly, I don't know that anybody's going to pull out a straight edge and draw their line using a straight edge. And then you're going to put arrows pointing to both directions. So each end is going to be an arrow. Okay, so use the slope and the y-intercept to graph the equation of f of x equals 3/5 x plus 1. So the number that you're adding to the x term on the right-hand side, that 1 is the y-intercept. So the y-intercept, the point that you're going to plot is 0, 1, which we already have plotted here on our graph. And then we're going to look at the slope. Our slope is 3/5. This is the rise over run. So what this tells us is that since this slope is positive, we are going to go up and to the right. If it were negative, then we can go down and to the right, or we can go up and to the left. So if it's negative, we would either go up and to the left, or we would go down and to the right. But since it's positive, we can go up to the and to the right. Now we could also go, just to confuse the BGBs out of us, we could go down and to the left. We could do that too. Probably shouldn't use brackets there. We're not going to do that. We're going to go up and to the right. So what's this mean, up and to the right? So the top number in our slope, the numerator, tells us the magnitude we're going to go up in the y direction. So it tells us we're going to go up 3 from the y-intercept. So we're going to go up 3, 1, 2, 3. And the denominator of our slope, the run, tells us the magnitude we're going to go in the x direction. So we're going to go 1, 2, 3, 4, 5. So we're going to end up at that point right there. And I've got some pretty slides here, so let's look at those. Okay, so the y-intercept again is at 3. The slope is 3/2. So the rise is 3. We're going to go up 3. And the run is 5. So we're going to go to the right 5. So we're going to start at 1 and go up 3. So we're going to end up at 4 for the y coordinate. And we're going to start at 0 and we're going to go to the right 5. So we're going to end up at x equals 5. So the point that we're going to end up at is 5, 4. 3 up from 1 and 5 over from 0, 5 to the right of 0. So we're going to end up at the point 5, 4. So now we have the line graphed. We take a straight edge, we draw a line through those 2 points and make sure we put arrows on each end. And this may be the method that you are most familiar with when graphing the equation of a line. As a matter of fact, as a teacher, as me, Lisa, my preference for graphing the equations of lines is the method we're going to learn in a second, which is intercepts. I think intercepts is the easiest way to graph the equation of a line. But it's been my experience for students, it's this method. So even if I give you a pretty equation that you can graph intercepts quite easily, you solve for y and use the slope and the intercept. And that's fine. That works just as well. Okay, so let's talk about two special equations of lines. The first equation of a line that's special, and I got my fingers quoting, is the equation of a horizontal line. If you think about a horizontal line, if it's a horizontal line, everywhere on that line, the y value is constant. So y is constant, but x can be anything. So the equation of a horizontal line is exactly that. Y equals a constant, y equals b. And we use the variable b because that's what we use for the y-intercept. So the equation of a horizontal line is y equals a constant. The slope of a horizontal line is 0. So that's why you don't see that mx anywhere in this equation. If we have the equation in slope-intercept form, and the slope is 0, then we do get the equation y equals b. If it's a vertical line, which is not a function, I mean, this violates the vertical line test everywhere on the line. The equation of that, though, is x equals a constant. If we look at a vertical line on the coordinate plane, let's draw a vertical line. Everywhere on this vertical line, x is the same value. It's constant, so x is constant. Y can vary. So the equation x equals a constant is the equation of a vertical line. So how would you graph y equals 3 in the rectangular coordinate system? That would be the horizontal line at y equals 3. Okay, what we have here is what is called the general form of a line. So if you take the equation either in slope-intercept form or in point-slope form, and you put everything on the left-hand side and you get 0 on the right, that's general form. And that's general form for all equations. So if you have 0 on one side and everything else on the other, then you are in general form. And general form is probably the least useful of all the forms of a line. There's really not anything you can do with it. Even to be able to use slope-intercept, you have to solve for y. To be able to use intercepts, you have to get the c, the constant, on the right-hand side. So general form is actually probably the least useful of all the forms of a line. But we're going to use it anyway. So let's find the slope and the y-intercept of the line whose equation is 3x plus 6y minus 12 is equal to 0. So this is general form. And as I said, not particularly useful. It's very useful in other functions. For example, the quadratic function, it's very useful to put the quadratic function in general form, but the line, maybe not so much. Okay, so how do we find the slope and the y-intercept if I have a line in general form? Well, the fact of the matter is I put it in slope-intercept form. So I need to solve this for y. Okay, so it's a good thing that we've solved lots of equations. The first thing we're going to do is we're going to move that minus 12 over to the right-hand side by adding it to both sides. So we're going to add 12 to both sides. So we get 3x plus 6y is equal to 12. Then we're going to move the 3x to the right-hand side so that we have the y isolated. So we're going to subtract the 3x from both sides. That is going to move that to the right-hand side. And I'm going to write the x first and the 12 second. Okay, so since I had positive 3x on the left-hand side, when I move it to the right-hand side, it will be minus 3x because I have subtracted it from both sides. And then I'm going to divide by 6. 6 divided by 6 is 1. Okay, so now the right-hand side can get kind of tricky. And you guys try all sorts of interesting things to simplify this, but there's only one thing you can do to simplify this. What you're going to do is you're going to write the 3 over the 6 and the 12 over the 6, and then simplify those two fractions. If I have multiple terms being divided by a single term, a monomial, that's what that thing in the denominator is called. If there's one term, it's a monomial. If I have multiple terms being divided by one term in the denominator, then I write each term in the numerator over that denominator. And now I can divide out a 3 minus 1/2 x, and I can divide 6 into 12. It'll go 2 times. So my equation in slope-intercept form is y equals minus 1/2 x plus 2. So the slope of this line in general form, the slope is negative 1/2. And the y-intercept is 2. Okay, so the one thing that general form is kind of useful for is finding intercepts. So if I were to take this equation in general form and stop right here, let me get my highlighter on. If I stop right here and don't go any further, that particular form of the line is very useful in finding the intercepts. If I know the x-intercept and I know the y-intercept, I know 2 points on the line and I can graph the line. Okay, so how do you use the equation of a line in general form to graph the equation? You can use this form to find the intercepts. To find the x-intercept of a line, remember, if you are on the x-axis, y is equal to 0. So to find the x-intercept, you set y equal to 0 and then solve for x. To find the x-intercept, the y-intercept, I can't talk. To find the y-intercept, you set x equal to 0. Because if you're on the y-axis, x is equal to 0. The x-coordinate is 0 on the y-axis. And you solve for y. Then you have 2 points. You have the x-intercept, you have the y-intercept. You plot those and you draw a line. Now this is my favorite way to graph the equation of a line. And it works very well in my math lab, except when the intercepts are fractions. And lots of times in my math lab, if the intercept is a fraction, you can't graph it that way. Very annoying. Okay, so graph this line using intercepts. Okay, this is in general form. So what I normally do is I normally move the constant over to the right-hand side. It just makes things a lot easier for me to do. So I'm going to take my equation. And I'm going to move the 6 to the right-hand side by adding it to both sides of the equation. Okay, so now I'm going to find the two intercepts. So the first intercept I'm going to find, why not, the x-intercept. And to find the x-intercept, I am going to set y equal to 0. Because if I'm on the x-axis, y is equal to 0. So that's what I'm going to do. In my equation, I'm going to set y equal to 0. So minus 2 times 0 is 0. 3x minus 0 is 3x. So I have 3x is equal to 6. Divide both sides by 3. X is 2. So my x-intercept is 2. So that's going to be the first point that I plot. So I'm going to plot on my x-axis. I'm going to go over 2 and plot that point. Okay, now let's find the y-intercept. To find the y-intercept, you are going to set x equal to 0, because on the y-axis, the x-coordinate of every point on the y-axis is 0. So we're going to set x equal to 0. Three times 0 is 0. 0 minus 2y is minus 2y. Divide both sides by minus 2. 6 divided by negative 2 is negative 3. So the y-intercept is negative 3. So the x-intercept was 2. The y-intercept was negative 3. So now we're going to go plot those 2 points and draw a line. So we're going to plot the point 2. The x-intercept is 2. The y-intercept is negative 3, and we're going to draw a line. Now, the reason I like this method so much, let me get my equation back. Is because it's so quick. So if I put it in this form, to find the x-intercept, I just take my finger, which you can't see me doing, and I cover up the y, completely cover up the y term. And what do you have? You have 3x is equal to 6. To find the y-intercept, I take my finger and I cover up the x. It's just a very, very, very fast way of graphing. So if it's in general form, for sure, I'm going to use intercepts to graph it. All right. So here are all the equations of a line. And again, a line is a function as long as it's not a vertical line. So all of these that we've talked about, except the vertical line, are functions. So point slope form, slope intercept form, horizontal line, which is a function, it's the constant function, vertical line, not a function, and then general form. And this little table is in the notes for chapter 2 provided for you in Blackboard. And we're going to skip this. All right. Any questions so far? Are you still there?
I'm here. I don't have any questions so far.
All right.
I don't know about everybody else.
I'm just glad I'm not talking to thin air. Always makes me feel better. All right. We are going to spend a little bit of time, and hopefully this won't take us too terribly long to get through this section. It's fairly short. We're going to spend some more time talking about slope. Now, the slope of a line is its rise over run. So the first thing we're going to talk about is what happens if we have a line that's parallel to a given line. Then we're going to talk about what happens if I actually have a line that's perpendicular. And what's perpendicular means? Perpendicular means at right angles. So if your house has been built fairly correctly, the walls and the floor of your house should be perpendicular to each other. It's not always true. Sometimes houses aren't built that well. Or the ceiling and the wall should be perpendicular to each other. But the ceiling and the floor, those should be parallel. Right? So we're going to talk about that first. And then we're going to talk about slope as a rate of change. Because the fact of the matter is, you can talk about the rate of change of a function even if it isn't linear. So far we've been talking about slope in terms of linear functions, lines, and that makes sense. You can look at a line and you can measure its rise over run and you can find its slope. But any function, we can find a rate of change between 2 points. How can we do that? We can take the 2 points, draw a line, and find the slope. So the rate of change of a function can be found by finding the slope of the line that connects those 2 points. And then we'll do that to find a function's average rate of change between 2 points. Okay, so parallel and perpendicular. And I just described this talking about hopefully the room that you're in. If you have 2 non-vertical lines and they are parallel, they have the same slope. So your ceiling and your floor of your house both have a slope of 0, and they are parallel to one another. So 2 non-vertical lines that have the same slope are parallel, or if they're parallel, they have the same slope. And then 2 vertical lines are parallel, even though their slopes are undefined. Okay, so how do we use this? So write an equation of the line passing through the point -2, 5 and parallel to the line whose equation is y = 3x + 1. So I want to find the equation of the line that's parallel to this one. But goes through the point -2, 5. So how do I do that? Well, to be able to find the equation of a line, I need one point on that line. I got it. -2, 5 is a point on this line. And I need to know the slope. And I know the slope of this line also, because the slope of this line, if it's parallel to the given line, it will be the same slope. So the slope is going to be 3. So the slope of a line parallel to this one will have the same slope. So the slope is 3, and it goes through the point -2, 5. So now we're just going to use point slope form to find the equation of the line. So y minus y1 is equal to m times x minus x1. So the slope is 3. We're going to put that in right there. And our point x sub 1 y sub 1 is going to be the negative 2, 5. So we're going to plug in negative 2 right here for x sub 1, and we're going to plug in 5 for y sub 1. So we're going to get y minus 5 is equal to 3 times x minus a minus 2. And I am going to take that minus minus and make it a plus. And if it tells me to put it in point slope form, I am done. That is point slope form. If they tell me to go ahead and put it in slope intercept form, I have a little bit more work to do. If I want it in slope intercept form, I need to distribute the 3 across. 3 times x is 3x, 3 times 2 is 6. And I need to move the minus 5, excuse me, to the right-hand side by adding it. So this is slope intercept. I have a cat trying to get in the door of my office. I don't know if you can hear it banging the door. All right, so this is the equation of a line parallel to the line that's given. And we might notice some things about this. It does have the same slope as the line I began with, but it has a different y-intercept, and that is necessary for two lines to be parallel. For them to be parallel, they do have to have the same slope, but they need to have a different y-intercept. Otherwise, if they have the same slope and the same y-intercept, they're the same line. Okay, what about perpendicular? Two lines that intersect at a right angle, 90 degrees, are perpendicular. So the relationship between the slopes of perpendicular lines are not as obvious as the relationship between parallel lines. So this figure up here in the upper right shows a line AB with a slope of C over D. So the slope of this line is its rise over run. So it's rising some variable C, and its run is some number D. So the slope is C over D. And if I take that line and I rotate it 90 degrees, what happens? Well, first of all, this rise of C gets rotated and becomes the run, but it's now no longer positive, it's negative because it's going up in the original line, but when I rotate it, it's now going to the left. So that value is now negative C. And the run, which is D in the original line, gets rotated around and becomes the rise in the line that's perpendicular. So the slope of a line that's perpendicular has a slope of negative D over C. So can you see the relationship between the original slope and the slope of a line perpendicular to it? What's the difference? Well, first of all, they're reciprocals of each other. So D over C is the reciprocal of C over D. So D over C is a reciprocal of C over D. And they're opposites in sign. So the original slope was positive C over D. The slope of a line perpendicular to it is negative D over C. So to find the slope of a line perpendicular to a given line, you take the slope of the line you are given, you find the reciprocal by flipping it over, and you change its sign. So the products of these two slopes of the line and the line perpendicular to it, if you multiply those together, you get -1. If you multiply a number by its reciprocal, you get 1. If you multiply a number by its negative reciprocal, you get -1. So to find the slope of a line perpendicular to a given line, you take the reciprocal and you change its sign. Don't forget that you have to change the sign also. So if two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of the slopes of two lines is -1, then they are perpendicular. A horizontal line and a vertical line are perpendicular. Okay, so find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 is equal to 0. All right, to find the slope of a line perpendicular to this one, I need to find this one's slope. So I need to find the slope of the line that I'm given. And to do this, it's in general form. So to do this, I need to solve this for y. Because I want to put this in slope-intercept form. Okay, so I have x plus 3y minus 12 is equal to 0. I'm going to move the minus 12 to the right by adding it. So if it's minus on the left-hand side, it's going to be plus on the right. I'm going to move the x from the left-hand side to the right by subtracting it. So if I move a positive x from the left-hand side to the right-hand side, it's going to become minus x. And then I'm going to divide by 3. And I'm just going to divide everything by 3. 3 divided by 3 is 1. I have negative x over 3. I'm going to write that as -1/3 x. And then I have 12 over 3, which is 4. So what's the slope of a line perpendicular to this one? I take the slope of the line that I'm given and I flip it over. And then I change its sign. So if it's negative, I make it positive. If it's positive, I make it negative. So the negative reciprocal of -1/3 is 3/1. So the slope of the line perpendicular to this one is 3. All righty. Rate of change. And there are people who think this is the most important part of college algebra, right here, this little topic. Slope is defined as the ratio meaning a fraction, a division, a ratio of the change in y to a corresponding change in x. So it's the change in y divided by the change in x. It's a ratio of those two things. It describes how fast y is changing with respect to x. So the larger your slope is, the faster y is changing, the faster we're changing in the vertical direction compared to what we're changing in the x direction. So the steeper the line is, positive or negative, means that we're getting more of a change in y to a corresponding change in x. For a linear function, slope may be interpreted as the rate of change of the dependent variable per unit in the independent variable. So now let's look at an example in real world. I got my quotes up again. Real world example where we're finding the rate of change. And this is the rate of change of a line, okay? So in 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. Use this information to find the slope of the linear function. So we're assuming that this is a line representing adult men living alone in the United States. Express the slope correct to 2 decimal places and describe what it represents. Okay, so how do we create the 2 ordered pairs that we need? We need 2 ordered pairs on the equation of this line to be able to find its slope. So since this is linear, we do have a dependent variable and an independent variable. So what depends on what? Well, the number of adult men living alone depends on what year you're in. So the number of adult men depends on the year. So our independent variable which we'll just call X, is going to be the year. And our dependent variable, which we'll just call Y, that's what we use typically, is going to be the number. So what are our 2 ordered pairs? Well, we have in 1990 that 9 million adult men lived alone. So in 1990, we had 9 million. So that's 1 ordered pair, 1999. Which I need to write down because I don't have my notes with me. And then the 2nd ordered pair, what do we have? 2008, there were 14.7. So our 2nd ordered pair is going to be 2008, 14.7. So now that I have the 2 ordered pairs, I can find the slope. All right. So slope, oh, I have it written down. See, I'm smarter than I think I am. The slope is the change in Y over the change in X. And you know, I can look at these slides like 5 minutes before I present them and forget what's on them. Hey, what am I going to do? Okay, so the slope is the change in Y over the change in X. So we're going to plug and chug. I'm going to make this X1, this Y1, this X2, Y2. Why not? 14.7 minus 9 over 2008 minus 1990. So we're going to take our handy dandy calculator out and we're going to do this calculation. So we have 14.7 minus 9, 5.7 over 2008 minus 1990, which is 18. So we're going to now divide 5.7 by 18. And I get 0.32. Okay, what's this mean? Okay, what are the units of my numerator and denominator? So units of numerator and denominator. Okay, so the numerator was millions of adult men. So we're going to, we're going to write millions over here. And the denominator was the year, because the slope is the change in the number of adult men living alone versus the year that you're in. So the slope is 0.32 million per year. What's this mean? This means since this is linear, It means every single solitary year, the number of adult men living alone increases by 0.32. So if in 1990, it's 9 million, in 1991, it is 9.32 million. In 1992, it's 9.64 million. So every year, the number of adult men living alone increases by 0.32. And why do I say increases? Because the slope is positive. And we saw from our data points, we went from 9 million to 14.7 million. So the number of adult men living alone is increasing over time. So the slope is positive, which is what we see. So every year, there are 3.32 million more men living alone than the previous year. That's because this is linear. It isn't always necessarily linear though. All right, so let's look at an example that's not linear. And this is the growth of a male child from the time he's born to adulthood. So this graph is a graph that's not a straight line. It's not linear. The average rate of change between any 2 points is the slope of the line containing those 2 points. So if I want to find this person's average growth rate, I can pick any 2 points on this curve and find the slope of the line that connects those 2 points. It's called the secant line. So the secant line is a line that connects any 2 points on a curve, not linear, on a curve. And I can find the slope of a line that connects 2 points. I know how to do that. It's a plug and chug. So what this tells me is the average rate of change between those two values. So if I want to know the average rate of change of this young man from age, put my glasses on so I can see, from age 13 to age 18, I can find the slope of the line that connects those 2 points. Because I have at 13, he's 57 inches tall. At 18, he's 76 inches tall. That's quite a growth spurt, by the way. So I can find the slope. And when I find the slope of the line that connects those 2 points, I am finding his average growth over that time period. Now, that doesn't mean he's going to exactly grow that many inches every year, because we see that he has a growth spurt. I mean, right in here, the slope, oops, sorry about that. PowerPoint's trying to help me. So I can see that right here, the slope is pretty steep, but right here, it's kind of more horizontal. So there are 2 different slopes in that time period, but we can still find his average growth rate from age 13 to age 18. So to do this, we find the change in Y over the change in X. So at age 18, he's 76 inches tall. At age 13, he's 57 inches tall. So the change in his height, the Y coordinate, is 76 minus 57. The change in his age is 5 years. He's 18 and he's 13 in the previous point. So it's 19 over 5. So the average rate of change is 3 4/5, and this is inches per year. So on average, between ages 13 and 18, he grew 3 4/5 inch per year. Now, he didn't grow 3 4/5 inch per year, because from age 13 to 15, he grew at a faster rate than he did from ages 15 to 18. So there are 2 differences there. And when you move on in mathematics, then you can get more concerned with these 2 different changes. As I said, he has a steeper growth rate from here to here than he does from here to here. And that's okay. But on average, over that 5-year span, he grew 3 4/5 inches per year. That's his average growth rate over those years. Okay, so now you can find the average rate of change of any function given 2 points. How do you do that? Again, you find the change in y over the change in x. That's what this is. But now we're writing it in terms of the function notation, and that's okay. I mean, function notation is good because it tells you that it is a function. So what do you do to find the average rate of change of a function between 2 points? You have to evaluate the function at the given x's. That's going to give you y. That's what this is right here. That is y sub 2. Y sub 2 is the function's value at x sub 2. That right there is y sub 1. The function's value at x sub 1 is the y sub 1. You evaluate the function at your 2 x's, you take the change in y over the change in x, and you have the average rate of change of that function between those 2 points. So let x sub 1 f of x sub 1 and x sub 2 f of x sub 2 be 2 distinct points on the graph of a function f. Then the average rate of change of f from x sub 1 to x sub 2 is f of x sub 2. So f evaluated at x sub 2, that's y sub 2, minus f of x sub 1, that's the function evaluated at x sub 1, so that's y sub 1, divided by x sub 2 minus x sub 1. So this is the average rate of change, which is so long to write, they don't write it. The average rate of change. And believe you me, not to overemphasize the importance of this, but my business calculus class right now, this very minute, they are in sections in chapter 2 where they're finding the average rate of change of functions. So they are doing this right now. Okay, so how do you find the average rate of change of a function? Well, first of all, you need to be given 2 points. So this function f of x equals x to the third is the standard cubic function, which we'll talk about at length later. So it looks something like this. See if I can draw this. Something like this. So you want to find the average rate of change of this function from x equals minus 2 to x equals 0. So what you're going to do is you're going to connect those 2 points using a line, and you are going to find the slope of that line. So we need to find the 2 points. So we have 0, f of 0 is 1 point, and -2, f of -2 is the other point. So what do I need to do? I need to evaluate this function at -2, and I need to evaluate this function at 0. So I'm going to first find, whoa, stop helping me, PowerPoint. I'm going to first find f of x sub 2. So I'm going to take my function f of x is equal to x to the third, and I'm going to evaluate this function at 0, which means to replace the x with the number 0. So f of 0 is 0. So my first point that I'm going to be using to find the average rate of change is 0, 0. Okay, then I'm going to evaluate this function at -2. That's going to be f of x sub 1. So now I'm going to evaluate the function at -2. That means to replace the x with -2. -2 times -2 times -2 is -8. So my second point is -2, -8. And now I find the average rate of change. F of x2 minus f of x1 over x2 minus x1. So that is going to be 0 minus a -8 over 0 minus a -2, which is 8 over 2, which is 4. So the average rate of change of this function from the point x is -2 to the point x is 0 is +4. And what is +4 again? +4 is the slope of the secant line, which I drew in blue there. It's the slope of the secant line that contains those 2 points. So to find the average rate of change of 2 points on the graph of a function, I will need to evaluate that function at a given x to find the y value. And then I just take the change in y over the change in x. All right, are there any questions? Anyone have any questions?
I personally can't think of any questions.
All right, well, if you don't have any questions, I am going to let you go. And I'm going to ask you to stay warm and stay safe. And hopefully we'll see you on Monday.
Yeah, I'm gonna ask everyone here to stay safe as well, including you, Miss Castle.
Thank you. All right, everyone. Thank you for showing up. Bye-bye.
Bye. Wait,
Yes, we completed 2-3 just now. 2-4. What did we just complete?
2-4, I believe.
2-4. So we should be through 2-4. Okay, any other questions?
I actually have a question.
Sure.
So the